All right. We are not done with the conic sections. 12.6 is on more on conics. So our conics that we had the parabola. One of our default forms of that is y equals a times x minus h squared plus k. Which I'm gonna rewrite real quickly as. I'm gonna put the k with the y. So these are the same things. Or we could have had x equals a times y minus k squared plus h. And again, I could move the h to the other side and have x minus h equals a times y minus k squared. Maybe I'll put these in parentheses, kind of handy to see them, because they all have this kind of thing going on in them. So those were our parabolas. Circles have x minus h squared plus y minus k squared equals r squared. And if I wanted to rewrite this, I would divide by r squared here. Ellipses. And we are hyperbolas. There's two forms here. So those are the equations we had. Let's make some notes about them when you have them all written down. Some general ideas. How do we recognize them when we see them? Looking at the equations for a parabola, what's unique about the parabola that the other three equation setups don't have?
It only has one variable as the squared.
Only one variable is squared. So only one squared variable. And if I'm going to rewrite this slightly different. All I'm doing is I'm moving the denominator out front and writing it so it looks like a fraction multiplied by it. And the only reason I'm doing it because I want to point out the next thing, which might make it stand out. So here, all of these have both squares. So here, coefficients are the same. The numbers in front, which is effectively 1 over r squared. If I write it in this form. And they're both positive. Their coefficients are different. but both are positive. And this is gonna happen even before you write, like if you get like some fucked up equation that's got no parentheses and you gotta complete the square a bunch of times. You can always look at the coefficients on the x squared and the y squared. It's always gonna tell you right away. Parabola, circle, ellipse, or hyperbola. And here. Coefficients may be different, usually are different, but they actually don't have to be on it. Cause we did this last week where we had the same thing as a circle basically, but one was negative, so they had the same denominator. The important thing here is coefficients are different signs. So like they can be the same or different. And if we look at ellipses versus circles. The closer A gets to B, the closer the ellipse looks like a circle. I mean, you know, if it's going just like 1.2 this way and 1 up. From a distance, you might not even notice it's back and not a circle. And we can see they're pretty close. Their equations are pretty close. The only difference is these denominators. And there's an idea that we're going to do later called eccentricity that measures roundness. We'll talk about that a little bit. Like I'm sure I have an eccentricity level.
I feel like measuring roundness is an eccentric activity.
Right. All right, you guys ready? Parabola. Let's go into more depth on each of them. The parabola, the only one I've defined for you guys is a circle. The circle is a set of all points equally distant from a central point. The definition for a parabola is the set of all points equally distant from a fixed line and a fixed point. The fixed line is called the directrix. The fixed point is called a focus. I'm gonna try to do this where it looks reasonable. There's a good chance this is gonna look like shit. Gotta get the right roundness on the parabola. So we'll say that's our parabola. Oh, I know how to do this. Pick the focus. And do the line.
Only thing is,
What? I haven't done anything yet.
sorry.
So that's our parabola. Let's say that our focus is here. I'll call that F. So it doesn't matter where we go to it from the graph. I'm gonna call this D1 in both situations. D2 is straight down the same amount. I did not draw this very well. The directrix is like that. And in a better picture, D1 equals D2 for each set from the same point. I'll show you one on like that's been computer generated that looks a hell of a lot better. So you might like doing this one better in your notes. So the distance from any point on the parabola to the focus is the same as the distance from that point to the directrix. So for you nerdy people that have played World of Warcraft. Does anyone play World of Warcraft?
I played it, but not much.
Okay, so in World of Warcraft, a hunter can have a pet. And you usually set the pet to the monster. And the monster, so your hunter or your pet is between you and the monster. I named my hunter Directrix, and I named my pet Vertex. And the target of our shit was our focus. And so it was, I got some math nerdiness shit in there. I named my rogue after the name for the Y value. No, X value. Y value is called the ordinate. The X value is called the abscissa. Abscissa is a fucking great name. All right. Back to this, and how do we find this shit from our equation? So, this distance here is the same as this distance here. I'm gonna call it P. Because everybody else calls it P. And the way you find it is if we're looking at x minus h squared equals, or ax minus h squared equals y minus k. That's like the way we started earlier with just the k on the other side. Divide by a. This is how you do it. Divide by a. So we have x minus h squared equals 1 over a times y minus k. And then the 1 over a is 4p. Where a equals 1 over 4p. This is a lot easier to go like, what the fuck? I realize there's some what the fuck going on, but when you do it, you'll see. There's no numbers here, so it's a little hard to. So let's say I have x plus 2 squared equals 8 times y plus 2. Let's say I'm already in the correct form. How could I find p?
Letters by 4.
Yeah, This is the same thing as the 4p. So 4p equals 8. Divide by 4, I get p equals 2. The other handy thing is, if I had drawn this fucking better, it's along the axis of symmetry. So it's p units away along the axis of symmetry.
So why is it 4p? I think that's where I got lost. It's
Why is pi 3.14? Why are magnets equal and opposite? Exerting equal and opposite forces.
I don't know.
If I were God, I could tell you why I made the universe the way I did. If you believe in God.
That's what I was gonna say, it's 2 units upwards for the focus and 2 units downward for the. Right?
Yeah, let's actually graph this right now. So let's graph this. First off, where is my vertex?
So
It is at 2,
Is
negative
it 2, negative 2?
It is. Excellent. That was Jackie. Jackie, where you at? She's hiding.
I'm not
Oh, I
feeling
also,
good.
on my birthday, I had bread savage, savage. I don't know, whatever the fuck the name is. I stopped over there in the morning before I went to the Mason Center. And took home an almond croissant and chocolate croissant and one of their afternoon buns to my wife. Pretty good. Alright. So let's draw our parabola. This might be easier looking at if I divide by 8. So this would be the form you would normally see it in. I didn't divide by, yeah, I did. I divided by 8 correctly. What?
So it's better.
Right? It looks better. It looks more natural that way. But I want to like help you to pick the 4p. I want to start in the right form. Well, our next one, we'll start in this form and go the other way. And I think rather than fucking trying to plot this the normal way, I'm gonna find the intercepts. So when y equals 0, I have, I'm gonna go up here. When y equals 0, I have x minus 2 squared equals 16. Or 8 times 0 plus 2. So x minus 2 squared equal, or take the square root. Is plus or minus 4. So x equals 2 plus or minus 4, which is 6 or negative 2. Those are my x-intercepts. I think that's enough. We decided p equals 2. And so the axis of symmetry is along here. That's my axis of symmetry. So I'm going to go up to and put a point. That's my focus. I'm gonna go down to. Put a point and make a horizontal line. This is my directrix. So to find the focus in terms of point, if I didn't have such a great graph like I do. Since this is going up and down, I'm gonna add. From the vertex, or from vertex. If it's opening up. We do H. K plus P to get to the focus. So here we got 2, 0. The directrix is a line. What does the equation of a horizontal line look like?
Y equals to that.
It's a y equals thing. So if you're not sure what the y value is, do k minus p. In this case. And we went down to 2, -2, down 2 puts us at -4, y equals -4.
So the distance that the focus is away from the vertex. Is equal to the distance that it is away. The directrix is away from the bottom of the vertex.
Yes,
So it's those are the same.
yeah, the closest point on the directrix is the same distance as it is to the focus.
The vertex is halfway between the focus. and the vertex.
Yeah, vertex is the midpoint between the focus and directrix. Well, yeah, the closest line on the point on the directrix.
You need to figure out what the focus is.
Yeah, so headlights. The little light bulb. Is at the focus. The convenient thing about a focus. For a parabola or a paraboloid when it's 3-dimensional like this. Is no matter which direction the light goes out from it. It all reflects straight. Parabolas make that type of shape. If you emit light from the focal point or the focus. If it's off a little, it doesn't do the same thing. It scatters differently. So that's headlights.
So we were looking at, in F&O, we were looking at a lightsaber. I guess the ones that were like built a long time ago.
Yeah.
Would have a parabola, because it's sort of like the cameras in like the 1940s, how they have like it's like half circle or whatever, but the beam is like shooting forward.
Right. Same idea. The light shoots straight forward. So like on a radio dish. Satellite dish, radio dish, satellite dish, it goes the other way. The lines are coming in. And it doesn't matter which way they come in, they. Like, let's say our satellite's up here. It's coming in, and no matter which way it goes. The transmission reflects and hits the collector point, the focus. And so all the data is collected from each little radio wave bouncing off the satellite dish. It all hits this focal point where the receiver is at. So we put the receiver at the focus. And that's what the dish does. The dish helps capture all those radio waves, and whereas there's radio waves from all over the fucking place. So there's lots of radio waves hitting this motherfucker, but very few, there's only from some direction. Is a whole bunch of it hitting it where it overrides everything else. It's kind of neat. So we use this kind of shit in science. Let me give you guys one to try. We're not gonna go to the nice form that we like so far. I'm gonna give you one that starts, has the same setup, but we're gonna do it with the y as the squared thing here. So find P. We'll do that together first. Any ideas?
Maybe one.
We're gonna set this is for P. So P equals -1. What does the negative mean?
That it's going down.
It's going down, or in this case, not down. Because here the y is squared. So we're either opening left or right. So with the
Opening
y
to the
squared,
left.
it means we're opening left. So with the y squared, we have either this or this. P equaling -1 says it's got to go left 1. So either be there or there. So the P being -1 kind of shows us that it's there. Because the focus is like right inside the parabola. We're going to be opening to the left.
There's no differentiation between up or down, left and right, it all works the same exact way. But the where 4P is, the X.
Yeah,
the
yeah.
Y, there's no change. So. It won't be the same.
So we're doing -5, 1. And that's my vertex. Which means my P is left 1 more. My my focus is right here. Which means my directrix is over here. Now, sketching the parabola. I'm going to find the x-intercept. So when y equals 0, I have -1 squared, which equals 1, equals -4 times x plus 5. So -1/4 equals x plus 5. So x equals -5 1/4. Which is, we were at -5, 1 right here, so that's not very far, that's right there. It's kind of like pretty flat. Use some symmetry to go that way. It's a flat look parabola. And of course, if we solved it for the setup that we're more used to, I would divide by -1/4, I have x plus 5. Or divide by -4. And I would subtract 5. Now. It's important to note here, this was pretty easy. 4p equals -4, but it requires writing it in a weird form. Right? If this is the form you're starting off with, and you remember the relationship between these changes. A equals 1/4p. You can take this right here and do that. This is A. Which is 1/4p equals -1/4. And not have to rewrite it in the other form. Here, you cross multiply, you get -4 equals 4p and p equals -1. So you don't need to rewrite the equation if you don't want to. But I hesitate to show that, like, I get iffy pointing that out. Because students remember 4p easier than 1/4p. And they'll do it on both of them, and 4p does not work here. 4p here would be, well, in this case it does. No, it doesn't. Because 4p here would make this p equals -1/16. So you don't want that, it's got to be the right form. All right. What did I do here? Oh, what's the value what's the coordinate at the focus and what's the directrix? What's the vertex first?
One -5.
-5. 1. The focus is 1 left. I go 1 left, it's -5 minus 1 more, so -6/1. What is this vertical line here? What's the general form of a vertical line? Horizontal was y equals. Vertical is x equals, right? And it's going through -4. Or -5 plus 1. All right. Y squared plus 2y plus 8x plus 17 equals 0. I only have one square term, which is a y. So I am going to complete the square on the y. And maybe I'll subtract over the other stuff to the other side. So I complete the square. It's +1. So I'll add, I'm going to do that in a different color here. So I add 1. And I'll add one over here. This ends up being y plus 1 squared equals negative 8x minus 16. And if I want to write it in a form that's more usable to find that vertex, I'll factor out the negative 8. And I get x plus 2. Find P and sketch this graph. And we'll do it together in a second. Keith, it was fucking crazy. On Saturday when we left the Mesa Center,
Yeah.
it was fucking gorgeous out, wasn't it?
Yeah.
Nice and sunny, cool breeze. I get home, I would stay at home for an hour and then my wife's like, if you wanna go have lunch at Vejar's, we should go now, cause it's about to rain. I'm like fucking error, this doesn't compute, like. It was fucking bright sunny, I sure as shit go out, and fucking an hour later, overcast, gray, dark gray, I'm like, what?
It happened on Sunday, again,
Yeah,
nice weather, and then boom, it started raining so hard, I think it almost kind of fell for like a split second.
it's crazy.
Um,
Megan looks like this semester is wearing her out. You look tired AF. All right, what's P? How do I find it?
-2.
P is -2. Set this equal to 4P. Where's the vertex?
-2, 1.
-1.
Two, -1.
It's gonna be a downward, 20 downwards.
Does everyone agree with Keith? It's going downward?
Yeah.
It's going left. X squared would be up and down, Y squared is left and right. The P being -2 tells us we gotta go -2 to the left. But the only way of knowing which way to go, up or down, left or right, is recognizing which one is squared. You're just gonna have to remember that. So P being -2 pushes us over here. Where does that make the directrix? It's on the y-axis, right?
Yeah.
That's not y equals 0, that's x equals 0. Or the y-axis is our directrix. That -8 really makes shit ugly. So I'm gonna use x-intercept and symmetry to find another point. We'll do y equals 0. So I get 1 equals -8x minus 16. So 17 equals -8x. X equals -17/8, which is like -2 1/8. Which is just like barely there. And if I go down 1, which means it's barely there. Y one, right? Was that not super fun?
I feel like
It actually was,
It's not too bad.
I feel like this makes sense to me, like how there's much more to this topic.
Right, there's more to it than just it's a fucking curve.
What we can do with it this might be kind of interesting, calculating areas and stuff under it.
You don't want to calculate area with shit unless you're doing like calculus.
I just feel like I've seen that somewhere. I don't know.
I gotta look at what the point of the directrix is. I can't think of any physical explanations. Rather than starting the next topic, I think we should just take a 5-6 minute break now. All right, let's take a look at what the other ones have, the ellipse and the hyperbola. Yeah, let's talk about their definitions first. They're almost identical. The ellipse is the set of all points. They all start with this definition. Whose sum, or the sum of whose distances from two fixed points is constant. So like, this is fixed point one, and this is fixed point two. D1 plus D2 is gonna be the same thing as D3 plus D4. Go to any point on the circle or the ellipse. Draw a line connecting to the two focal points. So the fixed points are the focuses, which plural is called foci. So the distance from the focal points to anywhere on the line, if you add them up, is the same for anywhere on the ellipse, which is deep. In fact, one way of drawing an ellipse by hand is you put like two push pins in something and get a length of string and make it like you tie a loop around, like the loop around the string, and then you just hold it taut against it and go like this all the way around. So that if the string is always pulled against the 2 points, and you draw this circle and it goes around and well, not circle ellipse. I don't know if this like the D1, D2, D3 plus D4 makes sense. Does the idea make sense? No matter where I'm at on the circle, if I connect to the 2 focal points, if I add those distances up, it's the same no matter where I do it on the ellipse. Hyperbola has almost the exact same definition. The difference of whose distances from 2 points is constant. Doesn't matter which one I do. Well. I want to say absolute value of this. Because if I do it on the other circle. And I call that D2. And I call that D1. D2 is shorter than D1, and so like, but the absolute value that like, depending on which way you do the subtraction. The difference between the 2 points is constant. Difference is subtraction. And sum is addition. So both ellipses and hyperbolas have 2 focal points or 2 foci, not just one. Now, let's take a look at where the center is. The center on the ellipse is here, the center on the hyperbola is here. where are the vertices? Vertex 1 and 2 are on the endpoints of the major axis there. And here, B1 and B2 are like the vertices of the inner, like the parabola shapes. So for the ellipse, the distance from the center to a vertex is greater than to a focus point. If I'm going from the center out to the vertex, it's further away. Vertex is further away from the center than the focus point is. And for a hyperbola, the foci are further from the center than the vertices, which is the plural of vertex. Vertexes is wrong. This is wrong. We say vertices. And for some reason, they have chosen to use the letter C to represent that distance rather than P. So dumb math people, and I don't use that in terms of like the unable to speak dumb. Dumb math people have labeled that distance to focal points C rather than P like the parabola. I don't know why. So don't ask. Now, a little bit more information before we start diving into problem doing this. One other concept we have here is eccentricity. As I told you before, it measures roundness.
The NC is distance to focal points from the line itself, from whatever the ellipse or whatever
Yeah, you see this from the center to the focal points.
center to focus.
Alright, so eccentricity. Is going to be. E equals, which is the letter for eccentricity. C over A. For. On ellipses. If A is greater than B. On hyperbolas. If the x minus h squared is positive. And it's gonna be E equals C over B. If B is bigger than A. For ellipses or on hyperbolas. The y minus k squared is the positive term. So E is something we're gonna calculate, A and B, those are in our equations. What's C? So for ellipses. C squared equals A squared plus B squared. That's just how it is. For hyperbolas. C squared equals. The absolute value of A squared minus B squared. God, that looks like shit. That way, it doesn't matter which one's the bigger one, if we get the absolute value, we keep it positive. If you look at the textbook has it written two ways. A squared minus B squared for. When x is the positive or when. When A is larger, that's weird. I said this completely fucking backwards. This is the mind, and it just dawned on me like. This shouldn't work either way. That's the -1. And this has that. I just use my goddamn notes. Alright. Let's write this again. C squared equals the absolute value of A squared minus B squared. Hyperbola. C squared equals A squared plus B squared. Well, fun things about eccentricity. We'll do some calculations with all this shit in a second. When E equals 0, we have a circle. When 0 or E is between 0 and 1. We have an ellipse. So when E is close to 0, it looks circle-ish. And when E is close to 1, it looks like an ellipse. It's a flat. It's flatter. When E equals 1. I don't know how you're gonna find this on a parabola. But when E equals 1, it's a parabola. So they kind of define that to be the parabola. I don't know where they're getting C. I have to look that up. And if E is greater than 1, we have a hyperbola. And this all stems from E equals C over A or B, whichever one it is. For ellipses, C is less than A. Or B, C or B. You're on the major axis. And for hyperbolas, it's the other way around, C is greater than A or B. So the top is bigger than the bottom for hyperbolas, and you're bigger than 1. That's a lot of shit that you don't really give a shit about.
You care?
What?
I think you care.
The eccentricity of Earth's orbit is, I looked this up earlier. I used to do this, if you look at my classes, like a previous class, I had a word problem in there calculating the eccentricity of Earth's orbit. It is 0.0167. So Earth's orbit is almost 0, the eccentricity. Which means even though when we draw it on like a picture, it always like looks very elliptical. If you actually do it, it's almost looks like a circle.
So yes, and it really is just the angle at which the Earth is that creates the seasons. It's not.
Yes, the actual distance,
It's just sun exposure. How much sun exposure does your region have?
right? It's kind of like if we have the ellipse and we've got our 2 focal points. As these get closer together, this gets more rounder. Until when they hit smack dab in the center and they overlap, they are now 1 point and you have the circle. That's kind of like what's going on with the focal point. And the focal point in the center for a circle is like the center, even though we don't call it a focal point.
So it's that the Earth is going around the sun in one plane of motion. And it's tilted to the side.
Yeah.
It's spinning not in line with the sun, but kind of canted off to the side like this.
Right. So we're more like this and like, let's say, let's do a better picture. Because it's almost flat. Or almost circular, so we're gonna go like that, almost a circle. Like one of these is the sun. One of the focal points is the sun for Earth's orbit. And we are tipped away. So this is the tip of the axis. So like the equator is like this.
That's cool. Alaska doesn't have this concept.
I have it tipped the wrong way. It's tipped the other way. And the orbit is like this. That's the equator. Because in summer, we are further away. But the North America is facing it better in the daytime. And in winter, over here, the northern side of the continent. Or the northern half of the country, not country, world. Is like tipped away, so the sun isn't hitting it as directly. So even though winter's distance is closer than summer. The tilt affects how directly the sunlight hits.
The day is short.
And that affects temperature.
So like when we have longer days, like Australia has shorter days? Or like, cause they're in the opposite seasons of us.
Yeah, so when we're facing the sun, we're in the sun's light more often, more longer than the southern hemisphere. Hemisphere, that's the word I was trying to fucking come up with. I'm like the lower half of the world. The hemisphere, southern and northern hemisphere gets more sunlight than the southern hemisphere, we're in the daylight longer. In summer, even though we're technically farther away. Alright, so enough about, that's just some applications of this. I'll tell you about hyperbolas another time, like where the focal point is. Like hanging bridges, I wanna say, how about hyperbolic curve? I think. Called catenaries. So let's look at an example and like work from there. Thankfully for these, you don't gotta rewrite them in another form. So what's my vertex? What's A and what's B?
Negative. 2, -1.
No,
-1, -2.
-1, -2. We say the X value first. What's A?
2.
Square root of 4 is T. B,
No, 3.
square root of 9 is 3. So. I go up 3, down 3. Left 2, right 2. Draw an ellipse. My focal points should be up and down C from the center. So I don't want to sketch them yet because I don't know what they are. I need to find C first. So for an ellipse, C squared equal the absolute value of A squared minus B squared. So C equals the square root of 5. Is that like 2.2? So up 2.2 from here would put it just above the x-axis. And down 2.2 is gonna put it right there. So focal point 1. To be exact, I'm gonna say -2 plus square root of 5. And focal point 2 will be -1, -2 minus square root of 5. Which is plus or minus C. right? Eccentricity. Since this, the major axis is this. Major axis is up and down. We're gonna use B. Know what that is?
Point 7. 5. 0.7.
Really? Okay, cool. Would never have guessed it was that close. Alright, so. Next problem. I mean, in the like the homework, they might ask you where the vertices are. And they may ask you for the intercept. Did the homework ask you for the intercepts on hyperbolas or ellipses or circles? Did anyone? Has anyone done any of the homework for? I don't know if the homework asked for the X and Y intercepts, but it should ask for the vertices and, well, you haven't done foci and that stuff till now, so that won't be till 2 this week. Let's give you guys one to try. How should I start?
Divide or both coefficients
Why?
in order to make a ellipsis.
What does it do in the equation? You're right, but I want to make sure you know why it's 4. Because I got 2 4s. It doesn't have anything to do with that 4.
Yes.
It has to do with this 4. We're trying to make that equal 1 over here.
Yes.
Let's say 1. It helps with A and B, to be honest, but you would never see it that way. No one's gonna like write it over 1. In fact, I'll do that in a different color. So calculate. Draw a picture. Figure out what C is. Figure out what E is. And we'll do it together in about 5 minutes. Alright, what's the vertex?
It's, 2x, -2y.
There's no X or Y in it, it's just 2 and -2. What's A and B?
1 and 2.
1 and 2. So if I sketch it. Oh, this sucks. I picked 2 examples that have up and down.
Sure, you can grab-
-2.
Yeah, it's 2 neg. That's out, out, stop and scrub alert. Fuck all that, wrong side, thank you. What are you talking about? I got in the right spot? Quit tripping. Nope, half I got it wrong. So how do I find C?
You.
Do 1 minus 4.
So we got 1 minus 4, which is 3, that's C squared. So C is the square root of 3, which is 1.7. So we're going up and down, not left and right, because the major axis is that way. 1.7 that way and 1.7 that way. F1 is at 2. -2 plus square root of 3. And F2 is at 2, -2 minus square root of 3. That's about -0.3. That's about -3.7. What's E?
Is. I got 0.87.
So E is C over what letter here?
B.
It's over B in this case. So square root of 3 over 2
0.87.
is about 0.87, yeah. All right, ready for some hyperbolas? No, this is why I only did 1 second section today. This is all 12.6. I use like the other books I've used to do the Foci and Directrix or Foci and Eccentricity. In the parabola chat section or in the, and it makes a section really long and really hard to schedule. This actually has a much, it's much easier to schedule it when you're doing it like this. Let's take a look at the hyperbolas. So let's go with x plus 3 squared over 16 minus y minus 4 squared. Oh, fuck it. Let's go over 16 again. I like that. Let's do that. That looks like some fun. Bless you.
Thank you.
This would be a circle, right?
What?
This would technically be a circle.
Nope.
Oh,
Why not? Because of the minus. All right, so vertex or center.
And
-3, 4. A and B. 4. So I'll do my box. I go left 4. And right 4. Up 4 and down 4. Trying to make my box fairly faint. We only really put it in as a graphing tool. My asymptotes go along the diagonals. Which way does this open? Up and down or left and right?
Left, right,
That's correct. Why is it left, right?
starting of the equation is x plus 3.
Yeah, the X is our positive one. So we're going like this. That looks like shit. There we go. The focal points are gonna be farther out from the center than the actual hyperbola. So they're gonna be somewhere along this line right here. So how do I find C here? For hyperbola, it's a squared plus b squared. C needs to be bigger than a or b.
Yeah, that's 16 plus 16.
Is that 5.5-ish, 5.6-ish?
Point, yeah,
And we went left or right. Oh, this is 4, so 5.4 should be, or 5.6 should be not quite 2 more away. So 2 away would be here. 1.6 away is there. So that distance there is 5.6, or the square root of 32. And we go almost 2 away past the vertex there, that's 5.6 also. So the vertices are plus or minus 4 along X from the center. That is -3 plus or minus 4, comma 4. So -7, 4 and 1, 4. The foci are -3 plus or minus C. And that's the 5.6-ish. So approximately -8.6 comma 4 and 3.6 comma 4. I know Keith did his, I think Keith did his, Keith and David, you both done the NASA emails,
Yes.
cause you need to respond by like 10 a.m. tomorrow.
I gave my student ID, I gave my driver's. Is that still okay?
That is not okay, it needs to be a government ID.
Well, I have my actual ID with me.
Oh, it's not a driver's license.
Yeah, well, I put yes, I have a driver's license.
Yeah, what do you
And then after, oh,
Yeah, yeah,
You told me yours was, you're like, one of them, was yours the one that was expired, but you had a renew, you were renewed and you went, nope. Send me a picture of your ID and I'll forward it on,
okay.
cause they won't allow you to change it and you need that. They gotta look you up and they don't have access to COS's picture database.
I was mentioning, I just got mine with this state. I had a Colorado license for a while. And I just got a new one for here, and so mine's a recent update. That would. That's what I was thinking. I don't know.
Which one did you submit?
I submitted the one from here.
That should work.
That's the one.
It's in the system. If you got one from here, it's in the system.
That's-
Any form of government ID would work, as long as it's not expired.
Okay.
Alright, here, let's give you guys one. Does your student ID even have a number on it?
Yeah, it's like 001.
Oh, your banner, right?
Yeah,
Yeah, they're gonna reject that, so forward me a picture of your thing to,
okay.
your driver's license tonight and I'll forward it on. What are we gonna do first?
Make, make the problem one, on the right side of the equal top.
That's right. You wanna have a 1, so we're gonna divide by 36. 36 is conveniently 9 times 4. So in the left one, the 9's cancel. And you got a 4 on bottom, and on this one, the 4's cancel. And you got a 9 on bottom. It's the vertex. Not vertex center,
So -1, -3.
no,
Oh, shoot.
-3, -1.
it's -3, -1. Remember, we gotta always do the X one first. What's my A and my B?
2 and 3, A, 2A. And B.
Nope.
Oh, shoot.
A is 3, B is 2.
Yeah. A always goes with X. Yeah, we'll do a quick sketch. -3, -1 is right here. We go left 3 and right 3. Up and down 2. I don't think my dots were these things are spaced very well. Up and down, left or right?
Up and down, okay.
Everyone agree?
First, two.
So my vertices are up and down B from the center. So we have -3, 1, and -3, -5. What is C? C squared is A squared plus B squared. 4 + 9 is 13. So C equals the square root of 13. I'm guessing that's 3.6, 3.7, somewhere around there.
It's 3.6.
3.6, okay. And so our foci will be from the center, that same thing. -3, -1 plus or minus square root of 13, which is 3.6. 2.6. Approximately that. And I didn't mention above, what is eccentricity here?
C over B, right?
For this one, it's C over B. What is it for this one up here? C over A.
C over B.
Whichever one it opens along, we're gonna use that letter. So here we got square root of 13 over 2. About 1.8. Up here we had C was square root of 32 over A, which was 4. 5.6 over 4. 1.4-ish. Please tell me that's about 1.4. I'm doing that in my head. I'm winging it.
That would just be root 2.
Yeah,
That's
because that's 4 root 2. Yeah.
Yes.
4 root 2 over 4 is root 2. Which is about 1.4. That is not how I was doing. I was doing 5.6 divided by 1 divided by 4. But I know square root of 2 is 1.4-ish. All right, it being 5 o'clock, so. No, you don't have to get the book out. You're welcome to stay. But lecture is done.
So just text you my or do you want?
Not text, you need to email it to me because I can't email, I need to be able to forward it to.
I was
You
gonna
don't
say,
have
just
NASA's
take a
number?
picture of it right now.
That again, I need to email it to him, and it's easier on the computer.
But,
What?
You don't have NASA's text number?
No,
So you're not cool like that?
I'm not cool like that, I don't have her phone number, I can't text it to her.
Gotcha, did you?
It'll get to the front door also, that's I.